Hey everybody, thanks for signing on here. We start slow in case we get some last minute ads here. My name is Jeff Jordan. I'm an application engineer supporting 3D printing here at GoEngineer, and we're going to be talking about 3D printing in professional motorsports today. I've got a nice presentation, and let's get rolling. So I know everyone has different backgrounds here. We're going to start with start general. Let's see, there we go. So 3D printing as a whole is making a big splash across all industries, but it's specifically changing the motorsports industry because of how competitive everyone is. Starting from a general sense, there are many different technologies that I'm sure people have heard of here. FDM, PolyJet, DMLS, SLA, SLS, and we've got an example of some parts here. What I want to concentrate on is that these are all working towards the same goals. So no matter what the technology is or no matter what the material is, you know, think of 3D printing as a more of a toolbox than like a magic bullet here. And our goals are to produce new, novel parts, more innovation, better results. And for motorsports specifically, what we're talking about is a better return on sponsor investment. So that's kind of an overall theme that I'd like I'll be coming back to. Novel designs, this one's pretty easy to, wrap your head around. We've got geometries that are either impossible or very difficult to produce using traditional manufacturing methods. We're always looking for reduced mass in motorsports. Oh, I actually forgot to mention, I have a background in motorsports. I previously owned a company that did wiring and electronics for motorsports, participated in racing all the way from stock car racing to a little bit of open wheel stuff, a lot of production car based racing. So I'm coming from, this is right in my wheelhouse. So anyway, so we've got mass reduction is always a key component, and 3D printing lends itself very well to that. The other thing that people in manufacturing and large industry are very focused on, but motorsports maybe not as much, is cycle time. So from the minute that you have an idea to having something usable in your hand, whether that's a prototype, whether that's an end-use part, the cycle time is really, really compressed with 3D printing because there's just fewer steps. We're going to cover a couple of those workflows and how they've worked for a few of these applications, but whether it's manufacturing, whether it's design and prototyping, the reduced cycle time is just as important as any of these other things. And from a business perspective, this would be talking to the team principal usually. You're talking about a reduced risk and cost. So in the design phase, you're going to be doing as much of the design as possible in the computer, getting that prototype that's faithful to your design, much less risk with 3D printing than outsourcing it or even machining it in-house. When you're taking these prototypes to manufacturing, we've got quite a few different technologies that help with that as well. And then end-use products, ideally, again, going back to the return on sponsor investment, if you develop a product and a sponsor that has helped you pay for your season can then make an end-use part out of that, you're golden, right? That's going to be a best case scenario for everybody, and we'll get to keep racing for the next few years, hopefully. So we at GoEngineer are a Stratasys value-added reseller. Stratasys, founded in 1989, one of the big pioneers of 3D printing. They currently have over 600 additive manufacturing patents. The big one for this presentation, Stratasys was awarded Motorsport Technology of the Year last year at Motorsport World Expo. Wow, that's a typo. Sorry about that. Motorsport World Expo in Cologne, Germany last year awarded Stratasys Motorsport Technology of the Year. So as everything that came out last year, we're talking electric vehicles, we're talking composites, all the technologies that have anything to do with motorsports, Stratasys was seen as making the biggest splash. GoEngineer is a value-added reseller, started in 1984. Company's been around for a very long time. Started selling Stratasys printers a few years ago, and we've been very successful. Last year, we were the #1 worldwide reseller of 3D printers for Stratasys. So we're coming from a place of knowledge because we're a great partner of Stratasys, we get to see a lot of the cool projects and a lot of the cool parts. And as an application engineer, that's where I get to have the most fun. So diving into some of these applications, I didn't want to spend too much time on the intro. The first one is motorcycle road racing, and this is just a great example that's, you know, nice to look at. These are sexy parts. So this was a MotoGP bike, 250cc class. We had the company did a design study of all of these aerodynamic parts. So people don't think motorcycles are as, aerodynamics are as important as they are on, say, an open wheel car or a production car. They actually play a pretty big role in how the bike functions, because all of these parts have multiple design criteria. So the front fender is the one that's most impressive to me, because that's a part that could not be manufactured any other way. They've got some ducts that feed. If I don't know if you're familiar with motorcycles, you're feeding the rotors at the top there. That's the most efficient place to do it. And ducting that air into the front fender really helps with drag with the front of the motorcycle. So they had a very cool idea with this, and obviously, this is the top level of motorcycle racing. This was a great place to test it out. Bikes are hitting, even the 250cc bikes are hitting 200 miles an hour. So this was an interesting design. They did a design study. They produced the part, and this was actually produced with a material called WinForm XT, which is an SLS material that's designed to replace carbon fiber in some applications. Lightweight, very strong, very rigid, and it's resistant to heat, because these parts do see some thermal load as well. So you've got this front fender, you've got the seat, which is the picture in the top, and then you've got a rear fender as well. These are great examples. The CAD to design study to printed part workflow, not only is it faster, but it saves a ton in tooling. These parts are traditionally made with carbon fiber. They're done with a mold, so you have to machine the mold. You would then lay in your carbon and vacuum bag it. Something like the seat that's in that top middle picture, you would have to do some sort of bladder inside, and it just becomes incredibly cost intensive and time intensive. And we're thinking about motorsports teams where your resources are severely limited. Even in the MotoGP level, they only have a few guys that are doing these doing the composites for the bike. So being able to directly print these parts is a huge time savings. And obviously, if we can do something that allows better overall functionality of the motorcycle, that's a huge bonus as well. This is one that I'm especially fond of, the Koenigsegg 1-to-1. This was 1 horsepower per kilogram was where they got that name from. They're going for the fastest car in the world title. And this is, I call it production automotive category, but let's be honest, it's pretty low volume. But still some very cool stuff, and a really interesting bridge, because Koenigsegg is really riding the line between one-off things where 3D printing is very popular, and production where 3D printing has some manufacturing applications, but you're not really 3D printing the end-use part. So we've got some very cool end-use parts here. The first one is the turbine housing. Turbine housings function based on volume and flow. At low RPMs, you would like a smaller turbine housing. At high RPMs, you'd like a larger turbine housing to get the optimal characteristics for a certain wheel. So the goal was he wanted low-end spool without having a huge engine, and he wanted high-end power. And this is, everybody that's dealt with turbochargers has some familiarity with this. So he designed this housing with I wish I had a cutaway view. There was a video where he showed a little bit of this really quickly, but he obviously didn't want to give it away. So you have some really intricate geometry in there with 2 flow patterns. One of them for low end, the other one for high end. They both are basically change direction and size in all 3 dimensions, and you have a flap that basically moves gases in between those 2 in variable levels. So not only were they able to design this, he was able to print it. And not only was he able to print it, but it was a half a kilogram, 500 grams lighter than their previous exhaust housing. And they were not using we're not talking about big rig truck exhaust housings. They were using an optimized housing before. So this is a really incredible thing. It's, metal 3D printing is something that Stratasys does not do at this point, but still, I had to put it in here. It's just too cool not to talk about. And so that's a win on all fronts. So you're able to, just like the MotoGP example, you're able to do something that was not able to be done using traditional manufacturing methods. In this case, you would have needed to make an incredibly complicated casting that they didn't see themselves as being able to do. And you were able to do it better, meaning even if you could produce it, it was able to be produced lighter. And so for low volume production, again, production car with air quotes, low volume production, 3D printing has a really great application. And the same thing with the exhaust tip. This doesn't seem like a big deal, but for something like a, whatever the car is, $2 million car, these aesthetic pieces really make a difference to Christian Koenigsegg, who makes the car, and whoever's going to buy the car. So they wanted this unique look, and it's actually a pretty big piece. It looks small there, but that's, it takes up 20% or so of the rear fascia. They wanted a unique look. The shape was not able to be produced by forming a piece of titanium, which is how the most cost-effective way to do it. And they didn't want to cut a piece out of billet titanium because it takes forever and it's hard on tools. And so what they did is they actually printed it. And so that entire exhaust tip is a printed piece. They're able to make each one different if they want, which was a big deal for this particular project. And they saved, again, a couple of pounds, almost 1 kilogram from their previous piece, which was also titanium. So, those weight savings all around the car add up. It gives it, again, saying, I have a printed titanium piece in the exhaust, gives it a unique flair. And he was very happy about it. There's tons of videos that go over how they use 3D printing in this particular project, and that's the one that you can just see him glowing about it. He loves it. So very cool application for, air quotes, production automobiles. Here we've got road racing using production cars. So this is a V8 supercar story. Nissan Motorsports Australia. V8 supercars, some of the best racing around, super competitive. The teams have a relatively tight rule book, but there's a lot of innovation down there, and the Australian market just loves it. So in a previous year, I believe it was the 2012 racing year, could have been 2013, one of the drivers had to be pulled from the car mid-race due to heat exhaustion. It was an especially warm day, and this was mid-season, and they didn't have Nissan did not have a solution. The inside of these cars is a fairly well-engineered environment. You can't, it's not like they can just drop a cool suit on the passenger seat there. So they needed to design a system that would keep the driver cool and would also not mess up the rest of the car. So they got with Evoke 3D, which is an Australian company, to design and manufacture a driver's cooling system. And this was, again, a mid-season deal. So they're doing development on the car. They've got, the rest of the Nissan Motorsports team has their goals. This was thrown in there at the last minute. Hey, we need to fix this. We can't have our drivers passing out. So Evoke 3D helps them. They work together. Again, we've got some really cool videos that show their coverage of this. They went and developed a venting system with a kind of a more traditional cool suit system. And when they were designing the exit, the exhaust of the hot air into the rear of the car, they realized that they had an aero problem. So they were able to fix that with aero elements as well, with printed aero elements. So overall, this was a huge story for Nissan, making them more competitive, more reliable, and for relatively low cost. They didn't have to redesign the entire interior. They were able to contract out a bunch of this. Very cool story for production car racing. This next one, let's see if we can get the slide to move. Here we go. This next one is a big one, and this is a lot of, I think, why Stratasys was awarded Motorsport Technology of the Year. They partnered with Straka Racing. This is I believe they're European guys, but I believe that the racing house is in the UK. They were developing the Dome S103 car, which competes in LMP2, so prototype racing, and using both PolyJet and FDM technologies. And the team principal was he's all over the media, motorsports media, talking about how great this is and how much it was able to help. Getting a question here. Where to find the cool systems? Oh, okay, so the cool suit videos. Valentino, I will post this stuff. We're going to basically publish this webinar, and I'm going to have links to all of this, so references so people can, see what I'm talking about. And again, we would love to have YouTube videos, but I can't exactly pause the presentation and play a 9-minute video. So I will have links to that. If you want to stay on after, I can actually just link those to you. Thanks for asking the question, and thank you, Dina, for forwarding that over. So the Straka car, prototype car, currently 10% of the car is printed, but in the next 10 years, he's estimating 70 to 80% of the car will be printed. So we're not talking about 10% of the car had 3D printing involved in its production. We're talking about 10% of the actual car they race on race day is printed, which is really cool from where we sit. As application engineers, we would love to see more end-use parts. So I've got a couple of ways that they're doing that here. And I'm going to have to manually change this guy. Next one. There we go. Wind tunnel testing. And Straka has been all over their Twitter posting these cool pictures because they look awesome. They've got these scale models, and the scale varies. Depending on how big the printer is, you can go up to different scales. The deal with wind tunnel testing is it's really expensive. So full-scale wind tunnel testing in Europe, there's a few places that do it. Few of the manufacturers have wind tunnels, rolling road tunnels that will do a full-size car. But here in the States, we only have one. And so what they do very commonly is they'll make a scale wind tunnel. They'll do a wind tunnel with really accurate measurements where they can put like a 6th size car or a 10th size car in there. And traditionally, you would make those models out of clay. You'd have some guy that's just working for a week to make a model of whatever the new design is, and then you'd go and test it. So they've got pressure sensors, they've got temperature sensors, they've got load sensors, and they're testing this little model to see what the aerodynamic effects of these designs are. Well, you can see these trays, they're printing 8 different designs at once and testing them all one at a time. And so you're able to do these prints very, very quickly. So the limitation becomes how fast can you CAD up these new designs, and you're able to go to production on these models very quickly. This team, they do a model, put a couple of them in the printer overnight, come back in the morning and test them. So FDM or PolyJet are both technologies that they've been using. The FDM models work really well once you get a little larger. Our largest FDM printer is a print envelope of 3 feet by 2 feet by 3 feet. So you're talking a very large model. That would be like a 6th scale car. Whereas some of these other models, if they're using a smaller tunnel, 10th size or something, you would use PolyJet. We have a much better definition there. You're able to get all of the, you don't have to do any post-processing really. Take it off the printer, clean the support material off, and test it. So you're able to use scaled wind tunnels. You're able to produce these with a fidelity to the CAD design that's unmatched by a guy sculpting clay. And you're able to do it quickly, and you can print lights out. So this works really, really well for the companies that are embracing this. Another one, again, one of the favorites over here, end-use parts. We love to see end-use parts being used, whether it's aircraft or race cars or devices out out in the marketplace. So we've got a couple of pictures here. The first one on the left, the camera and radio transceiver mount. So all of these race cars have payloads, which they have to carry. So this is part of part of professional motorsports. Is you're racing in a series. That series sells its airtime to a network. That network pays to be able to broadcast this video. They want onboard video. Everybody wants onboard video. And a lot of these cars are relying very heavily on telemetry. So, gone are the days where the car comes in and they plug a computer into a port. They don't want to wait till the car comes in to see what's going on. They want to beam back telemetry. So you've got these different radio and camera systems that need to be integrated into the car. You don't want to have to redesign the entire upper chassis piece to fit a different camera or a different radio. So what they did is they designed a modular mount piece that can be easily customized or reproduced for different payloads. and because it's all based on CAD, they know it's going to work. There's not, it's not like we have to prototype it and then, test it and then see if it fits. They know it's going to fit. So this one is printed in ABS. It's great looking, and that's actually what races on the car. The other one on the right here is a cockpit dash panel. So they were trying all sorts of different designs for different displays, and you can see that they've got AC vents in there. One of them points toward the driver, one of them points down. Maybe that's for circulation, maybe that's to cool some equipment. Regardless, they were trying tons of these panels, and they found one that they really liked. It's got a nice, you can see it's got a big angle on it. That piece would be not impossible, but fairly difficult to make out of carbon, and especially out of aluminum or something like that. It would be very time consuming. So they printed all these prototypes, then they ended up just using the prototype. So this is the ultimate in compressed design cycle. Is we went from design to end use part without a manufacturing stage. So very, very cool application, and of course we like that stuff a lot. Now onto more of a business side. This one was one of my favorites. Motorsport specific 3D print service bureau. So Toyota Motorsports Group, which was what they now call, it's had a few different names, but this is Toyota's F1 and WRC design house. They have a 300,000 square foot facility in Cologne, Germany, 30,000 square meters. And they, now that Toyota doesn't have an F1 program, they were wondering, what do we do with it? So they decided to team up with a company from the UK called 3D Parts to turn this into a motorsports specific service bureau. So they've got, it's the perfect place to develop a race car. So they've got 10 or more, they used to have 10, I believe they've added more, SLA machines, which during F1 development, when they were running the F1 team out of there, they were running 24/7, making thousands of parts per week. 10 machines running 24/7. They have two super pricey EOS SLS machines, which they, SLS can do a bunch of different materials. They use those for metal parts. They have 15 5-axis CNC machines. Carbon fiber layup for all the way up to full-size cars. So you've got an autoclave that'll do an entire car chassis or body. They've got two rolling road wind tunnels, one that's I think a 70% size and one that's a full size, that'll go up to something like 200 miles an hour. And the big thing for people that are using them as a service bureau in a business as large as a Formula One team is intellectual property protection. So this is encompasses everything that you would want to see from a service bureau, and they've got the experience, they've got the facilities, they've got the equipment, and they've got the ability to test right there. A lot of times you're testing using their, they have a shock testing, they have wind tunnel testing. So very cool story. And again, I've got some links for that we can go out. This is a little compressed here. So to recap, 3D printing is changing the motorsports industry by allowing us to make new and better parts, more innovation, better results. So this is from the design time, this is cycle time, this is risk and cost. The teams that are, just like in industry elsewhere, the teams that are adapting to this technology and really embracing it, like Straka, are going to be the ones that are more successful. There are a lot of elements to a motorsports team, but this one is wide-reaching enough that the teams that are on board with this are going to be more successful. And as far as technologies and brands, Stratasys is a huge one. They're definitely out there pushing forward to try to be as integrated as possible with this wave of motorsports teams that are embracing 3D printing. And here in the U.S., where GoEngineer is a reseller, I know I'm very interested in being a part of this. We don't have a huge motorsports presence here in Southern California, but I think it's something we're going to see more of and on more different levels. So we're very excited about it. So that brings me to our last slide. This is what we do. GoEngineer provides design and manufacturing tools with the expertise that enables customers to reduce costs, risk, and time required to go live with new technologies and ultimately new product. And that's especially key in motorsports, where you have to be continually innovating. So I've got a couple of questions queued up here, and I'd be happy to take questions from any of you guys that are here. From Valentino, how fast is the printing? That's a relatively complicated question. It's dependent on geometry and print technology. So we have printers all the way from FDM printers from $6,000 that print in a 5x5x5 envelope. And if you print a piece that maxes that size, you'd be a couple of hours, all the way up to, like I said, our Fortis 900 or our Objet 1000, where you're talking about print envelopes of 3 feet by 2 feet by 3 feet. And if you fill that space, you're going to be printing for a couple of days. A 40-hour, 50-hour print is not unheard of if you're going to print something that's that large. So if you have anything specifically, a lot of times what we do with service bureau stuff or people that are new to one of these technologies is we'll take an STL file and we'll run it through what we do is a time estimate, and so we can tell down to the to the gram or to the hundredth of a cubic inch how much material it's going to take, and we can tell down to the minute how long it would take to print. And so part interior and orientation and material, these all play a factor. So I'd be happy to take that offline, and my email address is here on this slide. My email address will be on the PDF that we send out. Happy to answer any of your questions regarding that. From Thomas Yang, interested in learning about the machine and materials more commonly used in the industry. There are a lot of machines and a lot of materials that are commonly used throughout the industry. There certainly isn't a standard, although I would, I would love to see more people adopting some of these technologies as a standard. What we basically see right now is ABS plastic is really versatile, but and it's relatively affordable. So that's what we're probably seeing the most adoption of. And the printers that print ABS are very wide-ranging, from less than $1,000 for a hobbyist printer all the way up to our Fortis 900 at something like $500,000. So ABS plastic is wide-ranging. In motorsports specifically, the high-end materials are much more widely adopted than they are elsewhere in industry. So we have Ultem materials that are very high temperature, 400 degrees Fahrenheit. They're totally fine. In FDM, we have WinForm XT 2.0 is an SLS material. We don't print that with the Stratasys printers, but a lot of the SLS printers can, and that's like a high temp and very rigid carbon fiber-like material. We have filled nylon materials. So maybe we need another presentation on different materials in motorsports. It sounds like a fun thing to do. Again, my email is here. If you have any questions, I'm more than happy to answer them. We really appreciate you guys checking out the webinar. Valentino, if I wanted to print 1,000 pieces in 2 hours, when we talk about mass production, if those were all the same pieces, I would probably start talking about other ways to make those parts. But when you start talking about those 1,000 pieces all being slightly different, then 3D printing becomes very, very attractive. So again, shoot me an email. I'd be happy to chat with you about it. Depending on geometry, 2 hours will depending on what it looks like, 2 hours will print quite a bit of stuff, but it all depends on how big they are, really. So we've got a question, send some videos how this is done. I'd be happy to. So I can put together a little PDF for everybody that attended today, and we'll host that as well, and send out some of my reference links and videos. Valentino, how does printing handle embedded chips? We can currently do embedded hardware, but with embedded chips, what you need is circuit traces, and currently that's the hardest thing to do. So there are a couple of printers that are in kind of a prototype stage that you can read about online that are doing printing circuit boards, but none of them are really ready for the prime time, and certainly none of them are ready for motorsports. So motorsports, I found through my about 10 years in the industry, motorsports is one of the most hostile environments for prototypes. If there is a way to break it, putting it on a race car will find that way. It's a lot like flying spacecraft, I think, in that sense. You've got heat, you've got environmental concerns with chemicals, you've got vibration, you've got large forces. So it's very difficult to print circuit boards that are going to be okay in that environment. So currently that's not a super popular application, but it's getting there. That's kind of the holy grail, is to be able to print embedded circuits and, of course, and then circuit components into our devices so that we don't have to produce them separately and don't have to assemble them. So great question. I think Dina's saying we have one more coming. I really appreciate you guys hanging out to ask some questions. Oh, titanium products like the let's cruise back here to that slide. Like the exhaust piece, or I mean, there's quite a few titanium products that are used. Titanium products are printed using laser sintering. So you have a powder, a titanium powder, and you pull a vacuum on this small environment, your print envelope. And so you have to do it in a total vacuum, otherwise you get oxidation. And you basically brush a 1 particle thick layer of titanium across the build plate. And you have a laser from the top that sinters that layer, so basically your X and Y in that 1 layer of Z. And then it brushes another layer of titanium dust over that, basically drops it down, drops the table down just a tiny bit, and sinters the next layer on top of that. So you actually get a piece that approximates the strength of a forged piece, because all of the particles are sintered in a 3D lattice to each other, similar to how a forged piece would be. But you do it with very little waste, because there's very little machining. So the powder that you use in the solid piece is of course solid, that comes out as your piece, and you try to recycle the rest of that powder. It's not an office-friendly technology like our Stratasys printers are. You pretty much need to use that in a special environment. They're very large machines, and they're environmentally, there are some extra concerns with the titanium powder, and if you aren't pulling a total vacuum and you get a little bit of oxygen into that build envelope, you can have an explosion. So it's definitely a more expensive and a little trickier way to make parts, but some stuff needs to be done in titanium. You can't do it in plastic. So that's where those have a very interesting application. Thomas, good source to learn about different materials in the machines. GoEngineer has a Stratasys page that has some very general information and a link to receive some more. Depending on where you're located, we may be able to help you with that. I'm sure we could forward you over to someone that can help you with that. So feel free to shoot me an email. I'm going to pop this back to the page that's got my email on it, jjordan@goengineer.com, and we can put you push you in the right direction. As far as learning about the different materials and machines, Stratasys.com has a ton of information that's in a pretty accessible format for the Stratasys machines. I can't speak too much for the rest, although Google is definitely your friend. Another one from Matt, videos on titanium design start to finish. Sure, it definitely seems like I should put together a little PDF with links to our videos here. Not a problem. Well, thanks, guys. I really appreciate everybody, coming to the webinar here and sticking on for some questions. And my email here should be on the screen. So definitely shoot me an email if you have any questions. And GoEngineer as an organization is here to support you guys as well. So if you can ping any of us, and we'll put you in the right direction. So thanks very much, and we'll be sending out an email with some links and a copy of the presentation.